we're going to learn how to add or subtract numbers that are presented in scientific notation from each other. Let's see. For example, we have 2.3 times 10 to the power of 5 plus 3.4 times 10 to the power of 5. How do we add these together? If you see that the tens have the same power, look at this. This is 10 to the power of 5, 10 to the power of 5. If the tens have the same power, you simply add the decimals together. So 2.3, I just add 2.3 to 3.4. And the result will be 5.7. So I put 5.7 times 10 to the power of 5. As simple as that. So if the power of the tens are the same, we add, or would be the same if it was subtraction. We add or subtract the decimal numbers together, right? Now, what if the powers are not the same? Look at this. 6.7 times 10 to the power of 7 minus 3.4 times 10 to the power of 4. Now, the tens, they don't have the same power. What do we do? First of all, you have to know we cannot simply subtract these two numbers from each other. No, because they're from a different order of magnitude. They are very different numbers. If you expand them, meaning if you convert them from scientific notation to normal representation of a number that you have seen so far, you will see that this one this one is from the order of 7 and this one is from order of 4. So you have two options: either convert these scientific notation to the normal presentations of numbers and then add or subtract them, or you have to convert either of these to the same order of magnitude. What do I mean? We have to convert these numbers in a way so that they have the same power on the 10. Okay? And it's usually easier when you convert the bigger one, like 10 to the power of 7, we convert it to 10 to the power of 4. So basically, we have to make 6.7 times 10 to the power of 7. We have to convert it to something that we still don't know, times 10 to the power of 4, right? Why? So that 10 to the power of 4 will be equal to 10 to the power of 4. So that we can subtract them from each other. Because they weren't equal before. So how do we do this conversion? Well, we want to convert 10 to the power of 7, so 6.7 times 10 to the power of 7 to something times 10 to the power of 4. Let's see. Compare this 7 and 4. The power of tens. How different they are? They are 3 units apart. So 7 minus 4 equals 3, right? 3 units. So it means we took 3 from the power of 10. Okay, let's influence that 3 into the 6.7, meaning I can write 6.7 times 10 to the power of 3 times 10 to the power of 4, right? This is the 10 to the power of 4 that I want, and I took 3 out of 10 to the power of 7. Remember, when the bases are the same, right, we know that 10 to the power of 3 times 10 to the power of 4 is the same as saying 10 to the power of 7. The bases are the same, we add up the exponent. 3 plus 4 equals 7. Just to review. Now, I can now influence 10 to the power of 3 into 6.7. So Now all I need to do is to 6.7 times 10 to the power of 3. What is 10 to the power of 3? That is 1,000, right? 6.7 times 10 times 10 times 10. This is 10 to the power of 3. Or times 1,000. So 6.7 times 1,000, you can even do it step by step if you want. So 6.7, one time if you multiply it by 10, that's 67. Then times 10 and times 10, that's 100. So 6,700. 6700. So I put that here, 6700. Now what happened? Now from 6.7 times 10 to the 7, now we got 6,700 or 6,700 times 10 to the 4. Now that the 10 to the 4s share the same power, we can do the subtraction. So I can simply say, I can just simply subtract these two, right? So we will have 6,700 minus 3.4 times 10 to the 4. That's the answer. So I just need to do the subtraction. The subtraction, you can either do it with calculation or in your head. So this will be 6. This will be 6 as well. And this will be 9 here. And then here will be 6 and 6 times 10 to the power of 4. You can double check that with your calculator. I just did that in my head. So we converted 10 to the 7 to 10 to the 4. Okay, let's see another example to make it more clear. Let's say 9.8 times 10 to the negative 4 plus 3.9 times 10 to the power of negative 7. Okay. Again, we can see that the exponents are not equal. One, we have power minus 4 and the other minus 7. They're not equal. So we have to convert them so that we can perform the addition. I said it's easier to compare the bigger one into the smaller one. So negative 4 is larger than negative 7. So we have to basically convert 9.8 times 10 to the negative 4. We have to compare it to something times 10 to the negative 7. So that the power of 10 becomes similar and we can perform the addition. Now, how much did we take out from negative 4? How many units? So I say we have negative 4 minus negative 7. We want to find out what's the difference between them, the exponents. So negative 4 minus negative 7, that's 3. So 10 to the power of 3 is taken out, so I'll give it back to it. Times 10 to the power of 3 times 9.8. How about that? And again, to review, we know that when we do 10 to the power of 3 times 10 to the power of negative 7, the result is the bases are the same. We add up the exponents. 3 minus 7, that's 10 to the power of negative 4. Again, just to review. I wipe it out. Okay. Now, I expand this guy so we can do the addition. 9.8 times 10 to the 3 or 1,000. Again, is 9,800 times 10 to the negative 7. Now we can perform the addition. So we say 9,800 plus 3.9, close the parenthesis, times 10 to the negative 7. So we do this addition, very simple, equals 98,0. Here will be 3.9 times 10 to the negative 7. Now, one thing we didn't discuss. Now, this guy, you can recognize this is not presented in scientific notation. So we can also do that and make it look like in scientific notation. How do I do that? Well, we have covered that in the previous sessions, introduction and the multiplication and division of scientific notation. So we want to convert it to scientific notation. First of all, I scan the number from left to right. The first non-zero digit is 9, so I put 9 and then the decimal point, and then the whatever digits they exist till the end. 8, 0, 0 in between counts, remember that. So 3, 9, and then after 9 there are zeros, right? So we don't write it. The continuous zeros after the last non-zero digit, they don't count. Doesn't matter if you write them or not, the number is the same. So 9.8039 times, now we have to figure out what should be the new exponent of the 10. Well, let's see. How far did we move the decimal point? We moved it from here to here, didn't we? So we moved it to the left, meaning we made the number smaller. Okay, how many positions? We moved it 1, 2, 3 positions. Okay, so we moved it to the left 3 positions. We made the number smaller, so we have to make the exponent of 10 larger. So that will be 10 to the power of -7 was originally -7. Now we want to make it 3 units larger, so -7 plus 3. This would be 9.8039 times 10 to the power of -7 plus 3, that's -4. This is the final answer represented in scientific notation. Hope you enjoyed it. Let me know if you have any questions.